Good evening, dear students. In this class, we are going to solve calorimetry numericals from B. This is the first question we are going to solve. First, read the question. 20 gram of ice at 0 degrees Celsius observes 10,920 joule of heat energy to melt and change to water at 50 degrees Celsius. Calculate the specific latent heat of fusion of ice. Specific heat capacity of water is 4,200 joule by kg Kelvin. So what we need to find out here, we have to find specific latent heat need to find out here. What is given? I is given here for 20 grams. It is at 0 degrees Celsius. It uses this energy to come this temperature. I mean here I will write this is the mass. This is the total energy. Of course, this is the temperature reaches by the ice. I mean water. So we have first the total energy can be written as Q equal to Q1 plus Q2. So initially the ice at 0 degrees Celsius, I mean it melt solid to liquid. Then how much energy is really absorbed by it? Q equal to ml. So it is ml. It is ml plus when it is melted, the water when the ice is melted, it is at 0 degrees Celsius and it rises to 50 degrees Celsius. I mean liquid state, liquid to liquid, the temperature is changing from 0 to 15 degrees Celsius. So we will use here mc delta t. Okay. I will add the given values here. 10920 equal to mass given in CGS system, convert into SI system. I mean 0.02 into L plus 0.02 into 4200 of the change of temperature is finally is 50, initially 0. I think you got it. And the next step we will get 10920 equal to 0.02 into L plus 84 into 50. Let's multiply. Okay, we'll write the step here. 10920 equal to 0.02 to L plus 84 into 50. This is equal to 4200. Then 4200 sent to the left hand side and subtract from 10,920. It is 920 minus 4200 equal to 0.02 into L. Subtract now. 10920. So you will get 6720. 6720 equal to 0.02 into L. Then L equal to 6720 divided by 0.02. Okay, let me see what will happen here. If you can divide divided by 0.02. You will get here 3 lakhs 36,000 units joule by kg. So how much energy is giving to the ice? 10,920. This energy utilized by the ice to convert the state from solid to liquid, and 0 to 50 degrees Celsius temperature rises. The temperature of water rises from 0 to 50 degrees Celsius. This is the first one. I think have you understood? Okay, I will go with the next one. This is the next one. Pause the video and try to solve it. What is given in the question? Let me see one by one first. How much energy is released when 50 gram of water at 80 degrees Celsius cools down to 0 degrees Celsius and then completely freezes? I mean, the water is at 0 degrees, 80 degrees Celsius freezes to 0 degrees Celsius. C equal to 4.2, L equal to 336. So this is the mass. This is the temperature 0 degrees Celsius. We said freezes. I mean, comes to ice state. We will see how we can find. So Q equal to Q1 plus Q2. Q equal to, first it comes from 80 to 0 degrees Celsius. The phase of the substance remains same, liquid to liquid. The temperature changes from 80 degrees Celsius to 0 degrees Celsius. So we will use the equation mc delta T plus, it is liquid to solid, I mean freezes it is. So we will use here ml, temperature remains same, phase changes. I don't do any type of conversion here, SI to CGS, CGS to SI. What are the values given? Directly I will take into the equation. So 500 here. Specific heat of water is 4.2. Temperature changes from 80 to 0. So final is 80 to 0, change of temperature, plus the mass is 500. Latent heat is 330. What you will get here, 50 into 42 into 80 plus 500 into 336. Okay, let multiply it. 50 into 42 into 80. You will get here 1,68,000. 1,68,000 plus 500 into 336. This is also you will get 500 into 336. It is also 1,68,000. 1,68,000. Now add these two. You will get here the energy is 3,36,000 joules. Okay, there is other forms we can write here, like Q equal to 336 into 10 power 3 joules. I think have you understood it? So by comparing the last and this, The last, ice converted into liquid. It comes to 50 degrees Celsius. This one, 80 degrees Celsius, the water freezes at 0 degrees Celsius. So it is reverse, almost same. There is no difference. To the next one, a molten metal of mass 150 gram is kept at its melting point 800 degrees Celsius. Put when it is allowed to freeze at the same temperature, it gives out 75,000 of heat energy. What is a specific latent heat of fusion? So what is given? This is the mass of the metal, melting point, melting point, and this is the energy given. I need to find the latent heat here. This is very simple to find. It is a A na. I will write here A. A it is Q equal to ml. Then L equal to Q by M. L equal to 75,000. Mass given 150 grams. Then how many kgs? Divide by 1000. Then you will get 0.15 kgs it. Let's divide it to get it. 75,000 divided by 0.15. It is equal to 5 lakhs. So L equal to 5 and 5 zeros. 1, 2, 3, 4, 5. Units you will get joule by kg. If you want, you can use. Otherwise, we will write it here. L equal to 500 joule by grams. 500 joule by grams. This is the one. Let's see the B. If the specific heat capacity of metal 200, how much additional heat energy will the metal gives out in cooling to minus 50 degrees Celsius? Okay, we need to find how much additional energy is required to find it. Okay, I will go with the next page or while writing the next one here like okay, so we have a equation here. Well known Q equal to mc delta T it is. So mass given 500 grams. Okay, I will take into the grams only it is 500 grams. A specific heat 4.2. What is the final temperature? Okay, I have taken so mass given 150 gram convert into kgs 0.15 kg. Initial 80 800, the final is minus 50 it is. So I will write here the delta T change of temperature is minus 50, final is initial is 800 equal to minus 850 degrees Celsius. C value is given 200. C equal to 200 joule by kg Kelvin. Okay, we know the formula here. Q equal to mc delta T. What is the mass? 0.0.15. C value is 200 into change of temperature is minus 850 degrees Celsius. Now multiply to get it. 0.15 into 200 into 850. So answer is 25,500 joule minus it is. I mean this is energy releases. So energy is releasing here 25,500 joule. Fourth one. A solid metal of mass 150 gram melts at its melting point of 800 degrees Celsius by providing heat at the rate of 100 watt. The time taken for it to completely melt at the same temperature is 4 minutes. What is the specific latent heat of fusion of the metal? So what is given here? Mass of the metal given 150 grams here. So this is M. Melting point 800 degrees Celsius. Power given 100 watts. The time taken for it completely melt at the same temperature. So temperature remains same. Time given 4 minutes. So I mean this is the power 100 watts. Time equal to 4 minutes. Temperature same. This is a equation we have. Power equal to heat energy by time. But we need to find here L, latent heat of fusion. So I will write it is ml by T equal to P. From this I will get the new equation like L equal to Pt by M. Mass given 150 grams. Convert into kgs, you will get 0.15 kg. Therefore, L equal to P value 100. How many minutes? 4. Convert into seconds. 4 into 60 by what is the mass? 0.15. That equal to multiplied 400 into 60, 24,000 divide by which is 24,000 by 0.15. Okay, here I will write therefore L equal to 24 divided by 0.15. You will get here 1,60,000. 1,60,000. 1,60,000 units joule by. Therefore, it can also be written as 16 into 10 power 4 joule by. So this one is a direct when compared to the previous ones. I think have you understood? I will go with the next one. A refrigerator converts 100 gram of water at 20 degrees Celsius to ice at minus 10 degrees Celsius in 73.5 minutes. Calculate the average rate of heat extract in watt. The specific heat capacity of water is 4.2 joule by gram Kelvin. The specific latent heat of ice is 336 joule by gram, and the specific heat capacity of ice is 2.1 joule by gram Kelvin. So it is in the ice state it is. Okay, see how do we convert it is? This is the mass given. Mass, it is at 20 degrees Celsius, and then we have to convert into ice at minus 10 degrees Celsius. This is the time. This is the L value. This is a specific heat seeker. So I will write it one by one here. The time taken by it. This is the latent heat of fusion, specific heat capacity of water, CW, and this is specific heat of ice, IT. So water to water first, water to water, water to ice, ice to ice. There are three processes here. So I will write one by one here. So first, liquid to liquid, then liquid to solid, then solid to solid. So here state remains same. So we will use here energy is Q1. This is the melting it, liquid to solid, I mean freezing it is. This is the Q2 energy, and solid to solid, it is a state remains same, temperature changes. The total energy we will write here, Q equal to Q1 plus Q2 plus Q3, that equal to MC delta T plus ML plus MC delta T. Okay, what are the given values? You can take directly into the equation except time. The remaining all are in CGS system. I will write it here. Mass 100. Specific heat of water is 4.2. Temperature changes from 20 to 0. So the change in temperature 20. 100 for mass. Latent heat 336 plus mass of water, I mean ice is 100. Specific heat is 2.1. Change of temperature 10. Let's multiply. What we will get it here? 100 into 4.2 into 20. You will get 8,400. Q equal to 8,400. And the next one plus 33600 plus the next one is 100 into 2.1 into 10, 2100. 2100 is 2100 it is. Now add this to 3, 8,400 plus 33600 plus 2100. Answer you will get 42,000 42,100 joules. But the work is not yet over here. In the question, he asked to find the power average rate of heat extract in watt, power equal to. Before that, I will write the time what is given here. Time equal to 73.5. 73 0.5 mint given. Convert into seconds. 73.5 into 60. You will get here 4,410 seconds. Then formula is power equal to heat energy by time, that equal to 42,100 divided by 4410. It is the units what you will get. Now divide it. 42,100 divided by 4410. It is equal to 9 point, yeah, 19 point. We will see small, I mean there is a small calculation mistake. Once again we will try to do that one. So 400 100 into 4.2 into 20 plus 100 plus 336 into 336 plus 100 into 2.1 into 10. Okay, so 44,100. 44,100. Okay, small mistake I have done here. It is a 4, the 4, not 1. 4 it is. 4. Then you will get here 10 watt the power. I think I will clear it. Don't have any doubt. The first five problems we have done today. In the coming class, we will do question number 6 to 10. Bye, boys and girls. Take care of you. We'll meet in the coming class.